Again, I'm not getting these.
Okay. All right. Before I take your question, I want to do the problem on the board here. All right. Do this one because I don't think I put a couple of graphing on the exam, but I did not put, or on the exam review, I mean, but I did not put something where you had to write your own equation. So we're going to practice here. We're going to write a sine and a cosine equation for this curve. Okay, so I want you to look at the picture, and what are some things you observe right off the bat? Has a vertical, the first thing I see is there's a vertical shift, right? And what is that? -1. So on the end of both equations, guys, the curves are the same. Whether you're thinking of it as a sine or a cosine, it's the same curve. So on the quiz, there's homework or somewhere, homework, I think it was, some of you were putting like a number here, but not a number here. That's impossible. If it's the same picture, then whether it's a sine or a cosine, it's down 1, right? That doesn't change. This also doesn't change, except for SIGN, positive and negative. This might change, but the height of those waves is the same, whether you're thinking of that as a sine or a cosine. So how high are the waves? 3. Now I may end up making something negative in a minute, but right now, I'm just going to put 3s. This isn't going to change, because whether it's a sine or a cosine, one period is the same length. So that number isn't going to change. Well, what is the period of this function? What is the period? Looks like it's 16 pi over 6, which I can leave that way or reduce it if I want to 8 pi over 3. And if the period is 8 pi over 3, then that number, 2 pi divided by it, has to equal 8 pi over 3, right? So 8 pi n has to equal 6 pi, and the pi's are going to cancel, so it looks like n equals 6/8 or 3/4. And again, they're both 3/4. It's the same picture. Now, this will change. Because if you're thinking of this as a sine curve, you're going to want to start it on its axis, right? That's where sines start, like at the origin. So if I'm looking at this as a sine curve, then my phase shift is going to be negative pi over 6. So if it's a sine curve, x plus pi over 6. If I look at that part of it, then it's a positive sine curve, right? So I'm going to leave my 3 positive. Now, if I'm thinking of it as a cosine curve, then I have to start up here. Would everybody agree with that? Which means my phase shift is now positive, what is that, pi over 2? So this is going to be minus pi over 2. And if I'm indeed starting here, then that is also a positive cosine curve. So the 3 is going to be positive. Right? Now, these are not the only 2 answers. Everybody sees we could start the picture here. I personally don't know anyone would do that, but you could. And if you did, then your phase shift would be 7 pi over 6, and your sine curve would be negative, upside down. Similarly, you can start down here and do a negative cosine if you wanted to. All right? So I wanted to get that one in, and now I'm ready to do whatever you need me to do. Lucy?
Can you do 24 on the semester 1 review? The
big review?
Yeah.
number 24. Function is defined parametrically. So that means I have parametric equations. And somewhere there's a point where t is 0. Well, that's pretty easy. If t is 0, my x is -1 and my y is 3. Right? That's pretty easy. Write the Cartesian equation, that means x's and y's, by eliminating the parameter. Okay, so t is the parameter. I need to get rid of the parameter. So that means I'm going to solve for t and plug it back in. So this would be the easiest to do that. So y minus 3 is t. With me, Lucy? So then I'm going to take y minus 3 and put it right here. So x equals y minus 3 squared minus 1. Now, what variables are in this equation? X and y, that's Cartesian. The Cartesian coordinate plane, the xy plane, that's a Cartesian equation. Done. Okay? Now I have to graph it. Well, anybody have any idea what shape this is? This equation is actually a fine shaped graph. Lorraine?
Sideways parabola.
It's a sideways parabola. We know, first of all, parabola because it's squared. Sideways because our BFF is y equals x squared. That opens up or down. This is y squared, so it's not up or down, it is sideways. Now, this is the vertex form of the parabola. Where's the vertex?
3.
It's, well, -1, +3. Why is it at -1, +3? Because points are always x, comma, y. And the y is 3. Think about this kind of thing, okay? Where's the vertex of this? Isn't it right 4 and up 1? This is exactly the same concept, but your variables are switched. So this is your y, and that's your x. So left 1, up 3. Oh, wait a second. We already knew that, didn't we? That's the point we get when we let t be 0. Okay, well that's all right, it's our vertex, and it opens sideways. So there's your graph. Now, let's say this equation wasn't something that you recognized, or maybe you weren't comfortable with it because it's not a function, so opening sideways and everything else. This point we got by letting t be 0. Could we get other points to graph by letting t be other numbers if we wanted to? Sure. And you could let t be as many things as you wanted to get as many points as you wanted until you could connect the dots and have some kind of a picture. Okay? All right, who else has a question about something?
If the y was like negative, would it have opened up the
Yep,
other
left,
one?
yep, left and down are negatives. All right, what else? Leah?
Could you do 19b?
Have you tried it?
I tried the 2 above it.
For the whole purpose of review, wait, 19D.
Yeah.
What-
Oh,
what am I
on the
on?
video review.
This 19D is y equals x cubed plus x squared minus 2. And I want to know if it's even, odd, or neither. What does even mean? When a function is even, it means what?
Symmetric over y.
It has symmetric over the y-axis. And what that means is that the sign on x has no impact on y. If you plug in 2, you get 2. If you plug in -2, you still get 2. It has symmetry across the y-axis. So to do that algebraically, you can determine whether it has symmetry across the y-axis by changing the sign on X. So, if you change the sign on X and clean it up, we get negative x squared plus x squared minus 2. Is that the same equation that I started with? Nope. So it's not even. All right, what does odd mean? Symmetric about the origin, which means if you change the sign on X, you also change the sign on Y. So let's see if it has that symmetry. Change the sign on both. Oh wait, this is supposed to say origin. I'm gonna change the sign on both. So I get negative y, negative x cubed, negative x squared minus 2. Now I'll clean that up. So negative y, negative x squared plus x squared minus 2. Now if I divide through by a negative, I get my x cubed, but I get negative x squared and positive 2. Is that the same equation that I started with? No. Nope. So therefore, this is a meter. Okay? Even functions have symmetry about the y-axis. That means if you put in 1 and get 2, when you put in negative 1, you also get 2. Changing the sign on x has no impact on y. That's what even means. Odd means if you change the sign on one, you're also going to change the sign on the other. All right, who else? Who else has something?
We do mine on that same sheet.
Did you try it?
I did.
All right, what
Also,
happened?
are you gonna post the answer key to this at all?
They're already in there, I think.
I looked last period, I might have looked
No, but I might have it.
What number was?
I might have it in that column to see.
Yeah.
I'll have to see. 9. Angle B is an acute angle. Stop right there. What does that mean?
Less than 90.
So which means it's in quadrant 1. So the tangent is 7/8. That's opposite over adjacent. So what do I need to do? If I want the sine, I need to. So 49 and 64. Is that 113? Which I don't think does anything. So I want the sine, so the sine is gonna be 7 over the square root of 113, opposite over hypotenuse. Right? Moran?
Can you explain 16 on this review? Vinny?
16? Yeah. What did you think about it?
I was just confused because to me it didn't look like a sine or a cosine curve because the way it's like.
It's not. 16 is a polynomial function out of chapter 2 and out of algebra 2. We're writing a polynomial function. It is not a sine or a cosine. Absolutely not. It has no symmetry. So when I write this, I start with my zeros or my x-intercepts. What are my x-intercepts? Negative 3, negative 1, and 2. So my factors are x plus 3, x plus 1, x minus 2. Now, here is the part you have to be on your toes. Look carefully at the picture. Am I going to put exponents on any of these factors?
It bounces on the left.
Oh, yeah, it bounces.
It bounces here and here, doesn't it? Remember, when you have a tangent 0, a 0 that just bounces off its tangent, that means it's squared. It's acting kind of like a parabola at that point. It's squared. And the only thing left is to figure out what that leading coefficient is, because that will determine which direction I open. This one's coming up from the bottom, and that's controlled by that coefficient right there. So how do I find that coefficient?
Multiply it out. Plug it in.
I plug in the other point. Remember, only the points on the x-axis give you factors. That other point is just random. So it looks like n is going to be 10/16 or 5/8. So there's your answer. There's your equation.
Can you do 2B on the mini review?
Did you try it, Lewis?
Yeah.
2B, find the y-intercept. How do we find a y-intercept? Let x be 0, all right. Let's let x be 0. We put a 0 in here. What does that tell me about t? No. 2t equals 3, so t equals 3 halves. And if t equals 3 halves, then y equals 13 halves. Is that right? That's your y-intercept. I don't care what the equation looks like. If you want a y-intercept, you're gonna let x be 0, period. That's it. That's how it's done, no matter what.
Going back to the last one, if like the coefficient is negative, then is the graph just like starts from the top?
Well, if it's odd, remember it matters if it's odd or even degree. This is a 5th degree. So that, yes, 5th degree, all odds start down and end up. If you put a negative in front of them, they start up and end down. Now, a problem like this, the negative will come out. If it's supposed to, this will come out negative. But, yes, that's the general principle. All right, who else? Let's go. Lucy?
29 on the bigger deal.
All right, what did you do with that?
Well, I tried to plug in, I didn't know if you're supposed to plug in everything into like a table and do like the,
You're writing a regression. Anytime you're doing a regression, you have to feed the calculator the points that you want it to write a curve through. So the points were 1, 1, and that's minutes and detentions. 3, 4.
oh,
4,
gosh.
11. Write the quadratic, using the quadratic regression capability in your calculator, and then what are these 5 minutes late? So we need to figure out how many detentions is 5 minutes late, and then what is the minimum? Okay, well that's probably stupid. But that's because I just try to make up a problem here. All right, let's see. So I go to, how do I put this in when I want to do something like this? Stat edit, right? So I need to, let's see. Okay, so 1, 3, 4.
You're gonna solve for that because you go like this. You get your equations right.
Once I get in, then I go back to stat and over to calc, and then pick the right regression. I got 1.83 x squared minus 5.83 x plus 5. Did you get that? Now we want to know how many, if I am 5 minutes late, how many detentions will I get? Well, what will I do? Plug it in? Okay, so 1.8. I got about, I'll round it off to whole detentions, I got about 22. Is that what you got? Now, kids, you remember, this is something I just sat down and made up. I didn't plan anything. This next question, I don't know what's gonna happen. But it talks about the minimum value. All right, now stop and think about that for a second. What shape is this? A parabola opening up. So when it asks for the minimum value, what am I looking for? Yeah, or the vertex, right? So what's our formula for vertex? Negative b over 2a. Whatever that is going to give me the x coordinate of my vertex. So I got about, and this is so dumb, I got about 1.6. Right? And then I'll plug that in. Again, you just got to go with the flow here. Who knows what this is gonna say. I got 0.36. Anybody else get that? Okay. So what that would mean is that if I graph this parabola, this would be the lowest point. So in terms of the problem, it means if he's 1.6 minutes late, he's going to get 0.36 detentions. Well, that doesn't make any sense because if he's not late at all, he's not going to get any detentions, right? So, but this is how you get the minimum. Does that make sense to you? And so the answer to the question would be the y coordinate, because the question is asking about minimum detentions, and when I set up my points, it was the y.
If it was maximum and if it was a
Can't do a maximum in this problem. Why can we not do a
well, I
maximum
mean,
in
if
this
it's
It
a downward
opens
facing
up.
parabola, would
Okay,
you
if it was an upside, if it were an
yeah,
upside down parabola,
would you
yes.
just graph it and then do find the trace and find the maximum point?
You don't need it with a quadratic, whether it's up or down, you don't need it. The vertex is always gonna be negative
Okay.
0 over 2a, and then you can plug it in, right? All right, okay, all right, what else do we need to do? What else, Corinne?
I just have a question, it's not a number review, but which chapter was it where we were doing like the larger equations of asymptotes? Is that like chapter
2?
Is it
Two. And let's see if there's something
Yeah. 1B.
like that on there.
There is, but they're just
Yeah,
not
X
like,
squared plus the factor.
They're not huge.
yeah.
It's
I don't know, I'm
only
just
one.
remembering like the,
Yeah, I've got one written down here somewhere. I mean, if that's how we want to spend our weekend time. So there's lots of questions that could come out of something like this. So a question that I know is on the review sheet is where are the asymptotes? So if we were going to be graphing this, that would probably be our first thing anyway, is figure out where the asymptotes are. So what would we do?
factors.
Factor everything. We always factor everything. So I'm going to have 2x plus 2x plus 3. And then over x, oops. I thought for a minute I might be having 2 vertical asymptotes, but now I can see I'm not, because what's going to happen? Yep, we're going to have a cancellation. So y equals 2x plus 3 over x minus 2. So, again, this could be one huge question like this, or it could be like the ones on the review sheet where you're just asked specific pieces of it. So, where are the asymptotes? Let's get those in the picture. The asymptote vertical is at x equals 2. And actually, so is the horizontal. Only y equals 2. So if the question said, where are the asymptotes, there would be the answer to that. If the question said, where is the hole, then that would be at negative 2, comma, negative 2 would give me a 2 on top, negative 1/2, Alright.
X plus 2. We cancel out X plus 2.
So negative 2, 1/4 would be my equal. There are several questions on there that involve y-intercepts. Where's my y-intercept?
Negative 3?
Negative 3. How do we find a y-intercept?
Make x 0.
Make x 0. No matter what kind of equation it is, make x 0. What if we wanted the zeros of the function? Remember, zeros, that's another word for x-intercepts. So there's only one, and it is also at
Negative 3.
negative 3. Wait, something's not right here. I got it. That's negative 1/4. You guys, you gotta catch me when I make that kind of mistakes. That asymptote, or excuse me, that hole is at negative 1/4. That looks better. Then I can connect that dots. So that could be lots of different questions, Dom.
Oh, I'm sorry, I missed it. How do you find the hole again?
Whatever canceled, that's your x value, plug it back in, and that gives you your y. So x plus 2 canceled, so I plugged in negative 2.
Okay.
So that makes 9. Test? Right. Lucy?
If it was instead of 2x squared, if it was just
Yes, it's the issue I have. What, Lucy?
so if it was 2x over x squared, how would you do something like that? Like it wouldn't be x squared over x squared. Like if that's a 2x plus 10x plus 12 over x squared and then 4.
What? And then what?
How would you find the horizontal
The
axis?
horizontal asymptote is always this comparison right here, Lucy. So if you have something like this, there's no x squared, but you still have that comparison. You
So
have
it's
to
just 0?
Yeah.
Okay.
Yeah. Test? I can't even hear her. Tess, what are you saying?
Since you don't have a horizontal asymptote,
Where? There's no problem up here that doesn't have a horizontal
how's the
asymptote.
one up there?
It has a horizontal asymptote. It's at 0.
Oh, I thought you like do synthetic division.
It's bigger on top.
Oh, no, you do that when the top is bigger than the bottom. How am I going to divide x squared into x? Did you just say take out an x?
Wait, x squared into it?
No, you can't. When you do polynomial division, you must have the top bigger than the bottom. Okay, otherwise there's no division. Okay? Okay? Got it? Okay, because in polynomials we can't add zeros and put decimal points and stuff, which is what we do in regular division when the top is smaller. Yeah, can't do that in polynomials. The top has to be bigger. If the top were bigger, there would be no horizontal asymptote. It would be a slant asymptote, and you would find it by dividing. Okay? All right.
Are we moving along or
I would love to move
Can we
on.
do number 22 on the mini review?
I have you tried it?
I looked at it and I couldn't figure out how to start it.
All right, we need to get clear on a couple of things here, folks. Looking at the problems is not the way to prepare for this exam. You have got to do the problems. All right, so her question is, I looked at this, and it says no calculator. I have to name some points that lie on that curve. Well, you can do this lots of different ways. One way to just remember, for example, our unit circle, if x is 0, and x is the angle here, so I'm looking at the angle. If the angle is 0, then what is the cosine of it? If the angle is 0, what is the cosine of 0? It is 1. 1 over 1. Exactly. Because cosine is x over r. So since the radius is 1 and the x-coordinate is 1, the cosine is 1. Oh, wait, but I gotta add 1, so that would be 2. Because the cosine is 1, but I got a plus 1 on it. All right, so then I'll move up to pi over 2. What's the cosine here? Cosine's never undefined. Cosine is 0 plus 1.
It's 22.
And then let's come to pi. What's the cosine over here? Guys, what's the cosine over here? -1. Then I gotta add 1 to it, so that's gonna give me a 0. Alright, let's go down here. What's the cosine down here? 0. But I'm gonna add 1 to it, so that's gonna be 1. I'm gonna go 1. Alright, let's go to 2 pi. Now's when things get really easy, because isn't 2 pi the same as 0? So whatever happened at 0 is gonna happen again. And what about 5 pi over 2? What if I just keep going around my circle? Same thing as, aren't I just gonna repeat myself now? So there are my 6 points. So that's one way to do it. Now there are infinitely many points. You don't have to use these. I just use those because they're the easiest. You could also have graphed the original equation, which would not be difficult to do because there's nothing weird going on there. So you could graph this equation. It's a cosine lifted up 1. So these points are pi over 2, pi, 3 pi over 2, and 2 pi. So see how at 0 we're 2? And at pi over 2, we are, that's kind of hard to see, but we'd be at 1. And at pi, we're at 0. And 3 pi over 2, we're at 1, and so on. So you could get your points off of the picture if you graphed it carefully enough. You could do that. Okay? Yeah. All right, what else? What else do we have? We got 13 more minutes. Here's a question that's very similar to the one we just did. It says, oh, and it says just name one point that lies on this curve. Name one point that lies on that curve.
0, 0.
Yeah, 0, 0 is the most obvious. There are lots of points you could come up with, but 0, 0. Couple of reasons. First of all, at 0, the sign is 0, so times 2 is 0. Another reason is when you graph that, right there it is, 0, 0, pi 0, 2 pi 0, pi over 2, 2, 3 pi over 2, -2. I just happened to see that one. Yeah. All right, what else? Okay, we are aware we're taking this first thing in the morning, right?
Best time of day.
Don?
The additional review, number 5.
Which one? 5, A, B, or C? C?
B.
D? Wait a minute, which one am I doing?
B. 5B.
5B? Okay, well, that equation is a parabola. And if we add the 3 to the other side, it's actually in vertex form. So the vertex is at -5, +3, right? So when you're talking about parabolas, if it's in vertex form, you can just look at it. If it's not in vertex form, -b/2a. We'll give you the vertex every time. Okay? They're all easy. Zoe. If you do, the formulas will be given to you. My guess is they're not on the review sheet, so it wouldn't be a focus of my study. This would be a focus of my study. I'm allowed as an honors teacher to slip some random stuff in, stuff we've learned, not stuff we've never learned, but stuff we've learned. But by and large, I want you to do well, so I've given you, this is what you really need to know, right? Sarah,
Can you spell on the video review, please?
have you tried it?
Yeah, I don't think I'm using the right version.
All right, what formula do we use when we're talking about bacteria? PERT. So we're going to use PERT. And we need to know how long it will take for 123 to become 567 if their growth constant is 0.112. Remember, any percentage needs to be changed into a decimal, right? So what's our first step? Divide. And then what are we gonna have to do? Log both sides, we'll use ln because of the e. So Sarah, we got log or ln, natural log, 567 over 123 divided by 0.112. ln 567 divided by 123, close parentheses, divided by 0.112. I got 13.64. Days. All right, what else? We're down to 8 minutes. What's gonna cause you to sweat tomorrow? Hopefully nothing. What did you do with it? Lewis?
So for how many do you have for 28 days? I'm putting 28 for T.
Yep, so Lewis is doing number 20 on the mini review. And he said for problem A, all I'm gonna do is plug in, I'm finding P of 28. So that's 140 over 1 plus 3 times 28, that's 28. All right, can you do that, Lewis?
Yeah.
Okay. So then the second part says, what is the maximum number of deer? 140. That's your limit to growth, right? This is a logistic function. The numerator is the horizontal asymptote that caps the problem. So 140 is your max number. When will there be 100? Put 100 over here and solve this. Right?
Yeah.
So can you do that?
Yeah.
You sure?
You can just solve it out.
Yeah, 100 plus 300 times 0.8 to the x. So I'm multiplying this over here, get rid of the denominator. Now I got 300, 0.8 to the x equal to 40. So 0.8 to the x equals 4 over 30. I'm gonna divide it by 300. Now I will log. So x log 0.8 equals log 4 over 30, and then divide by that. So I'm gonna do log 4 over 30 divided by log 0.8. I got 9, about 9. they got 9 days. Or years, days.
Wait, Miss Ford, what'd you plug? Can you just repeat what you plugged in your calculator? Sorry.
This divided by this. I'm solving for x, right? Just make sure you close all the necessary parentheses. Okay, what else? Marin?
On 23 on the meter view, the 2 coming before, like 2 plus 3 cosine 2 is that the same as it coming after?
Is addition commutative?
Yes.
Yes. Plus 2 is plus 2. Yep. Yep. That's your vertical shift. Lucy?
When you're doing 18 on the menu view, are you getting a common denominator?
Yep. You're subtracting 7, getting a common denominator. Yep. You cannot, that's an inequality. So you would have to approach it like this.
Okay.
And then you're gonna get a number on the top here to simplify all that. And then you have 2 dots on your number line.
Yeah.
Yeah.
On the right above that one.
Okay, what did you think about that, Sabrina?
Find the axis,
Find the what?
symmetry.
Yeah, so x equals negative b over 2a.
Yeah.
Okay.
Is that the whole problem?
I
Because
don't
it wants
know.
the maximum height.
Okay, is that the maximum height?
Yeah.
No, that isn't the maximum height.
That's the vertex.
Okay, it's part of the vertex.
That's the
This
x
is the
portion, not the y.
equation. The equation looks like
Plug that
this.
in.
So that is a parabola, that's why I can do that, because it's a parabola. Opening down, right?
Right. So you're solving for the y.
Now I know that the x or the t is 2. So I'll plug it back in and get another number. And in the vertex, this is your time.
Yep.
And this is your height. So the equation is set up that way. X is time, height is y. So it actually, this gives you both, there's 2 questions there. This gives you both the when and the how.
Is it 66?
Yep. I erased it already, but yeah, we did. You did a couple different ways.
Is there a test on it of 100?
I mean, we don't percent.
So the 3 points is
So she get a 90, you got a 90.
yeah. And you already put it in.
I already put the cans in, I haven't, it's automatically add those in.
So there's, you're still adding more?
No. All right, the sheet that I gave you, I came around and handed out paper, everybody got it, right? Okay, we're not doing anything with that paper until after exams are over, maybe after Christmas is over. But when we come back together, which will be mid-January, because we have J-term. When we come back together, that sheet needs to be done. Okay? I gave it a 4-1, 4-6 recap. Why do I want you to do this paper? Yeah, kids, when you walk in this room next time, we're doing 4-7. And then we're doing 4-8, and then we're having a test. Right? So we need to stay on top of the materials. I